Hello friends, in this video we will solve the following question. Among SF4, BF4-, XeF4 and ICl4-, the number of species having two lone pair of electrons on the central atom according to Vesper theory is, the options are as follows. We need to look at these cases individually. In the first case, sulfur has 6 valence electron. I'll put 6 valence electron around sulfur. This is not the correct way of representing the electrons around the sulfur, but to make it easy, I'll keep the 6 electrons separately. So these are the 6 electrons around the sulfur. Now, since there are 4 fluorine, 4 electrons, and this electron will be with this fluorine, this electron will be with this fluorine, this electron with this fluorine, and this electron with this fluorine. And these electrons will be lone pair. It will be paired, but it will be a lone pair. So in case of SF4, I'll draw it neatly. So here there is sulfur and there are 4 fluorine, and we have only 1 lone pair of electron. So this is not the species that we are looking for. In case of BF4-, we have the boron. Boron has 3 valence electrons. So I'll put 3 dots around boron in this way. Now we have 4 fluorine. Now how to accommodate 4 fluorine? Since we have a minus here, okay, the minus charge indicates that we have another electron that we can put it around boron, which brings the negative charge. So I'll put the dot here. Now we have 4 electrons. I hope you are getting it. Boron has only 3 valence electrons. But since there is a negative charge here, we can add another electron around the boron to get the negative charge. And then 4 fluorine surrounding the boron. 1 fluorine here, another fluorine here, next fluorine here, and the 4th fluorine here. And it will be having a negative charge. So if we are observing, there is no lone pair of electron around BF4-. So in this case, the lone pair of electrons on the central atom, which this is the central atom. So we don't have any lone pair of electron in this case. So this is not the this will not be counted in the answer. In the case of XeF4, the central atom of course will be xenon because there are 4 fluorine atoms. Now when you draw Xe in the center, xenon will have 8 valence electron. So let me draw the 8 electron. All the electrons I am drawing it separately, not paired. None of it will be paired. It is wrong representation, but to make things clear, I will be putting them separately, all the electrons. So 1 electron here, 1 here, all the 8 you can put around Xe. Now there are 4 fluorine atoms as you can see here. So 1 electron will go with this fluorine. So another electron, I can draw it with this fluorine. 1 electron with this fluorine, and next electron with this fluorine. So there are now 4 electrons, those are free. Now if you pair them up, they will be called as lone pairs. Now if you are observing, now there are 2 lone pairs in case or on the central atom of XeF4. So this can be counted in the answer. So we have 1. In case of ICl4-, I of course the central atom because we have chloride as 4. Now iodine itself has 7 electrons, 7 valence electrons I can say. All the electrons I am drawing it separately, all the 7 electrons around the iodine. Now this is not the correct representation, again I'm saying, but I am for to make it easy to understand, I have drawn it separately. Now if you are observing, there's a negative charge on this molecule, so I can draw another dot here. Okay. Now there are 4 chloride ions that we have to accommodate. One chlorine here, the next chlorine here, the next chlorine here, and the next chlorine there. Now you are observing that there are 4 electrons again, and once they pair up, it will be called as lone pair of electron, because they are not participating, so they are lone pair, lonely. In this case, again there are 2 lone pair of electrons. So in the option, as per the question demands, we have the option A, which is the correct answer.